All right, guys, today we're gonna do problem 2448, minimum cost to make array equal. I initially decided to create a video solving this problem because I felt that most of the solutions that are within the discussion section of this problem are far too complicated and rely too heavily on a strong, college level math fundamental understanding. Okay, if you look at the discussion section for this problem, the answers are going to be like, oh, well, if you know the rules of integration, you derive this function, it's always convex at this point. Like, essentially, it requires a strong calculus based understanding in order to solve the problem, and it's really not necessary, right? The way that I solved this problem didn't require any advanced mathematic understanding. You do need to understand how to kind of write through operations and figure out relationships between things, but you don't need to know what the derivative of something is, or the relationship between functions and if they have min points or max points or whatever, right? So with that said, let's go ahead and get right into this. And to be completely honest, I solved this problem I think like 2 days ago, so I've already kind of forgotten what I had to do. So you're going to kind of see me in real time rediscover what it takes to solve this problem, which I think is a good activity in helping you understand the way that you should be thinking through problems, especially hard problems. Okay, so you're given two zero-index arrays, nums and cost. Okay, so you have two arrays, one's nums, one's cost, consisting each of n positive integers, right? So they're the same length. You can do the following operation any number of times. Increase or decrease any element of the array nums by 1. All right, so if I have, x, y, z as an array, what are the operations I can do? I can do one operation to make it, I don't know, x plus 1, y or z. Or I could do another operation and do, x plus 1, y minus 1, z, right? So I can take any element and I can increase it by 1 or I can decrease it by 1. Make sense? Okay. The cost of doing an operation on the ith element is cost of I. Okay. So every single one of these elements has a corresponding cost associated with doing one of these operations, right? So if I want to make x to x plus 1, it's the cost of x to do that, right? If I want to make y to y minus 1, it's the cost of y to do that. So the total cost of doing these two operations would be cost of x plus cost of y. Hopefully that makes a little bit of sense. If not, when we go through the example, everything will become far more clear. Okay. Okay, return the minimum total cost such that all the elements of the array nums become equal. Okay, so just as a quick example, right? If you have like 7, 6, and 5, right? I'm trying to make them all equal in the end. So I might like minus 1 from this to make it 6, 6, 5, right? And then I might add 1 to this to make it 6, 6. Oh, don't do that. To make it, you know what I'm saying? To make them equal at the end. I don't want to get all superstitious and get people to close this video for that reason, but yeah, so right, you're trying to make them equal in the end, so you're going to minus some stuff plus some stuff to try to get them all to be the same, right? So with that said, let's look at this example. So in this example, we have 1, 3, 5, and 2. All right, that's nums. And I'm going to make the array cost, and I'm going to put it right above so you see the cost of each of these operations, 1 and 14. Okay, so what this basically means is we're trying to make this array the same in the end, right? So they're obviously not all the same, so we can make them all 1, we can make them all 4, we can make them all 1,000,000, we can make them all, we're trying to make them all equal in the end, right? And the operations of changing them one by one is the costs here, right? Now, the first thing you might notice is like, it seems crazy, like changing 2 is really expensive, right? If I change 2 to 3 or change 2 to 1, it's going to cost me 14. If I change 1, changing 5 is pretty simple, right? It's a low value. So it turns out that we can make all the elements equal to 2. Now, and that kind of makes sense, right? Because 2 is so expensive, it makes sense that you wouldn't want to change it, right? It's like, you're so expensive to change, let's try to bring everybody to you. It's probably cheaper than changing you one time, right? If you have a really inefficient car and you're trying to meet somebody, everybody with the efficient car should probably go to the person with the inefficient car because it costs so much more for them to go to you than for you guys to go to him. Something like that, okay? So to make all these 2, since we already know the answer, we can kind of think about what operations would be required to do that, right? So to make 1, 2, I'd have to do 1, and then I'd have to add 1 to make it 2. To make 3, 2, I'd have to do minus 1 to make 3, 2. To make 5, 2, I'd have to minus 3 to get it to 2. And to make 2, 2, I'd have to do 0 operations to get it to 2. All right. Now, these are the number of operations that I had to do, but there's a cost associated with them, right? So I had to do one operation that costed me 2. I had to do one operation that costed me 3, and I had to do 3 operations that costed me 1. So in total, that costed me 8, and that's why you see the answer is 8 right here. Right, so basically all that's going on here, right, so we have the initial array. We're gonna say we're trying to make them all equal, and it turns out that to make them all equal to 2 is our best option. And to do that, 1, I'd have to add 1 to it, which is going to cost 2. To make 3 to it, I have to subtract 1 to it. To make it 3, to make 5 to it, I have to subtract 1, subtract 1, subtract 1. So I have to subtract 1 3 times. And each of those is going to cost 1, so that's going to be a cost of 3. And then if I add those all together in the end, I get 8. Hopefully that makes a little bit of sense. This one, right, is the example where, you know, you're kind of already done, right, because the system is already all equal, so you don't need to do anything, right? So these costs are kind of irrelevant. All right, so how do we go about this problem, right? Without going down this weird, like, convex function rabbit hole, right? What we really need to do, right, in order to figure this out is we need to look at the values that we can change, you know, the values that we can change the array to and what the cost will be associated with that, right? Like here, we think about 1, 3, 5, 2. Like, what's the cost to get it to all to be 1? What's the cost to get them all to be 2? If we know what the last element is, right? If we know the element it's going to end up at, it's pretty easy to calculate what the cost would be, right? Right, if I have a generic array, you know, 1, 2, let's just say 1, 2, 3, 4, 5, right? I can figure out the cost pretty easily. Say like, okay, I'm trying to make these all equal, right? Let's imagine they all have a equal cost here, all equal cost of 1. You know, I could say like, how do I know what the minimum is? Well, I probably should start trying destination arrays, right? So it's like, what if I made them all 1 at the end? How much would that cost? Right? And then it's just the same game as before, right? Like, oh, to make this one 1, we add 0, cost 1, so that's plus 0. To make this 2 1, we have to subtract 1, and the cost of that is 1, so it's plus 1. To make this 3 1, we have to subtract 2, and the operation of do that is, so it's plus 2. To make the 4 1, we have to subtract 3, right? Cost of that is 3. To make 5 1, we have to subtract 4, the cost of that is 4. Right? And then we add all those up, and the 4 plus 3 plus 2, 5, 9, 10 equals 10. Right? And we can do the same game again. Right? 1, 2, 3. And we say, okay, well, the cost of making them all 1 is 10. What about the cost of making them all 2? Okay. Well, to make them all 2, now I have to do plus 1 here. Right? And the price of that is 1. To make 2 2 is 0. So the price of that is 0. To make 3 1, you have to do 2. So the price of that is 2. To make 4 1, you have to do 3. To make 5 1, you have to do 4. The price of that is 4. So 4 7 8 9. So the cost of this, oh, and this one is 1, is still 10. Right? So we're just going through, right? What if I wanted to make them all 0 just for the sake of argument, right? So to get something different. And I'm just running through the operations. What if I wanted to make them all 0 at the end? Well, to make 1 0, I'd have to do minus 1. So that's going to be cost 1. To make 2 0, I have to do minus 2. So that's going to be cost 2. To make 3 0, I have to do minus 3. So cost 3. Make 4 0, minus 4. Cost 4. To make 5 0, minus 5. Cost 5. 5, 9, 10, 15. So obviously, you know, there's cases where it's better and there's cases where it's worse, right? Like this one only costed me 10 in the end. This one cost me 15 in the end, right? So depending on your resulting value, you can think about like, okay, if I try this value, what would I get? If I try this value, what would I get? If I try this value, what would I get? So let's try to formalize a formula for what I'm doing here, because right now I'm kind of just like chicken scratching, like, oh, you know, do this and put this here and put that there and minus 1. But what is the actual general formula for how much this operation is going to cost? Okay. So here's where it gets mathematical, but it's not going to be as mathematical as like the, you know, advanced derivative convex function kind of solutions that you'll see in the discussion. Okay, so let's generalize this case here, and let's say that our cost array equals C1 C2 all the way to Cn. It's always good to use these kind of, now this is very mathematical. I'm sorry, I know I said I wasn't going to. This is as mathematical as I'm really going to get, but I like to just kind of lay out how things look generally, so then you can kind of think about what your formula is going to look like, okay? So you have cos1, nums is the same length, right? We'll call that n1, n2, n3, n4, n5, all the way to nn, okay? Now in the end, I want them to all be the same value x, right? In the end, I'm going to have an array, like a final array, where they all equal x. Now, again, I haven't solved this problem in like 2 days, so I've kind of already forgotten what the direct line is here, so I'm kind of just walking through this with you guys right now, okay? So I'm going to go get my dog, because my dog is like screaming and yelling for some reason. So don't go anywhere. Please, Max. Ya. ¿Por qué estás gritando? No puedo entender. All right, so what you're gonna do right now is you're gonna look at my dog, because apparently, here's a little break for you guys right before we go through solving this. Look at this perrito. Look at him. He does not understand anything. What does it mean to be alive? He doesn't know. He doesn't get it, you know? And he might be happier than all of us. So something you have to ask yourself is, does becoming more intelligent really make you happier, right? Does it lead to a better quality of life? Because my dog barely understands anything, and he seems like the happiest guy I've ever met. So I don't know. Maybe this won't make you more intelligent. Maybe it'll just make you more confused, and then in your confusion, you'll become less intelligent, and then as a result of that, you'll be more happy. So maybe this is productive. I don't know. But let's go ahead and get right back into this, right? So at the end, everything's going to be the same value x, right? We have the nums that we started with. We have the cost of each operation. And then for some x value, there's going to be a total cost of changing all these things, right? Okay. So what is that cost, right? Well, I have to get my nums value to x, right? How many times am I going to have to decrease or increase nums, right? How many times do I have to decrease or increase nums? That's nums minus x, right? In this example up here, for example, when I wanted to make 5 into 2, well, this is like my final x value, right? These are my nums and these are my costs, right? Well, how many operations did I have to do? Well, I have to decrease 5 3 times. Why? Because that's the difference between these two things, right? So I had to do 5 minus 2 times 3, right? And that's how much, that was the cost of doing this, right? The cost of making 3 into 2 was 3, is the difference between them, right? Because I have to do how many operations, how many times do I have to change 3 to get it to 2? Well, that's the difference between them, right? So that's how many steps I have to do, and then the cost of that is 3, and I messed up already, I apologize. The cost of this is 1. Right? And I did the wrong color. Right? So the cost of this is the price to, like, what's the difference between me? How many times am I going to have to do this decrement operation, right? I'm at the decrement once, I'm at the decrement twice, I have to decrement 3 times, right? Because that's the difference between them. I hope that's intuitive. And the cost of doing that is 1. Okay? For 3 to get to 2, well, what's the difference between them? How many times am I going to have to decrease? Once. And what's the cost to get there? 3 each time. Okay, to get 1 to 2, that's going to, well, it's not 1 minus 2, right? Because now I'm incrementing. So really it's supposed to be 2 minus 1. And what's the cost of doing that? 2. Okay, so since we have this kind of weird switchy thing, we should probably just do the absolute value, right? So the absolute value of what the number is, right? Minus whatever final x value I want, times the cost of that thing, right? That's the price to get to each thing. So we'll run through this again where we said the price was 8 using this formula for each one just to show you that this works, right? If you are unsure about a formula you've written, of course it could be right for just one case, but usually if you just run it against an example, right, that'll indicate to you, all right, this is actually, we're good to go. Okay, so we have the absolute value for our first value, n of I is 1. the final value is 2, 1 minus 2, and our CI value is 2, which equals, or we'll just do each one, and then we'll sorry, it's always hard to know exactly how you're going to do it. Okay, for the next one, we have the absolute value of 3 minus 2 times 3, because that's the price, right? So 3 is the number I, right? 2 is the X value we're finally ending up at, and the cost is 3. To get 5 to 2, this is one idea here, plus the absolute value of 5 minus 2 times 1 plus the absolute value of 4 minus 2 minus 2 times 14. All right, and then just to make things super clear here, we'll paint these red. So you know that these values, which values are corresponding to which other values. Right, so this is the formula. So what's this? This is, let's just simplify this on the fly. Okay, so this is 1 times 2, which is 2. This is 3 minus 2, which is 1, times 3 is 3. This is 3 times 1 is 3. This is 0 times 14, which is 0. So 6, 8 equals 8. Right? So what I'm basically saying here is that this generic formula works for determining what the total cost is, right? You have to do the whole sum, though, from I equals 1 to n, right, to find what's the total cost of making all of the numbers x in the end, right? And in our example, x is 2. We have these costs. We have these numbers. If we run through this formula for each of the individual values we're going to have to change, we get the same thing, which is 8 as what we did with the manual process, okay? So the value here, right, is, well, it's the absolute value, right, of the sum from I equals 1 to n of I, x of I, c of I. Oh, not x of I, just x, sorry. Okay. So this is the value. Now I'm kind of like, oh, maybe the math, my brain wants to go to the math formula now, but that's just a personal preference because the way that I've structured through this is so funny. But, you know, you want to minimize this. You want to make this as small as possible, right? So you want to find an x that minimizes this value. So you want to find the x that minimizes this sum. Okay. So you could do this for a bunch of x's, but it would take n time each time, right? So this would be n squared because you'd have to look at an x value, then run through this formula, see what the result is, look at another x value, run through the result, see what the result is, and keep doing that, right? So instead, let's just break this up and think about it in terms where we might be able to reuse information. Because right now what we could do is we could break this formula, right? And you could just try every x value in the range, right? You could try all the possible x values, right? From the smallest value in your array to the largest value, right? Because if it's smaller than the smallest, then you're just pushing things further. But you try everything in the range. Does that make sense, right? You could try 1, 2, 3, 4, 5, right? You could try, you would never try 6, right? Because that would just be pulling 5 farther, right? You're pulling everything. So you could try everything in the range for x and just say, does that work? Does that work? Does that work? Does that work? Right? Doing this formula, right? And that's fine, right? That's not a bad idea at all. But the problem is it would take too long with the way that this problem is structured, right? Because n is 10 to the 5. So you could look at all n values in the range. So that'd be 10 to the 5 values, sort of. And then you could do n operations to figure out what the result would be and then just do the minimum one, right? But that'd be too slow. So let's try to find a way to do this over and over again without having to reuse the same information, okay? So let's expand out this sum. So really this is n of I, n of 1 minus x times c of 1 plus the absolute value of n of 2 minus x, c of 2 plus dot, 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 all the way to the absolute value of n of n minus x times cn. Okay. Now, one problem with this, right, is this absolute value is I'm having trouble even looking at this and determining how I can try to group things and reuse information, right? So what I'm going to do is split it up into two cases. I'm getting too mathematical now. It's so crazy how that always happens, right? So I'm going to get rid of the, right, and, you know, the absolute value just means the difference between the positive difference, right? So what you could do is you could say, we'll do n of 1 minus x times c of 1 plus, you know, n of 2 minus x, c of 2 plus dot, 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 to a certain point where the n value is less than x. Or would it be the other way? So first we'll do x minus the n value for all the values. Just doing a general case here. So it might be the first element that, you know, whatever. All the way to the case where at some point n will be greater than x. So if we have this system sorted, I'm losing control here. Just give me a second. Where then the order will switch. It's crazy how hard this gets, man. So what I'm basically trying to articulate here is at some point, right? At some point, there's going to be a switch where, you know, there's these values in the beginning. They're basically saying n has to increment to get to x, right? But here, n has to decrement to get to x. So the difference is positive this way and positive this way. And the only reason I'm doing this is because I'm trying to group these things together so that I can try to find a formula. When they're stuck in this absolute, there's nothing that I can do, right? So we'll treat these as two different cases up here and then over here. And we'll say that that's that k value where things change. Okay, so let's just imagine that this was the case here first. Okay, x minus n to the k, c to the k. See if we can try to get some information out of this and pull variables out and see if we can get general things that are true. Okay, so we have xc1 minus n1c1. We have xc. Why'd I do it like that? All right, just give me a second here. I'm doing some algebra. xc2 minus n2c2 plus dot, 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 xck minus nkck. All right. Now, there's variables that I can form. I have x, and I can do c1 plus c2 plus c whatever all the way to ck. And then I have just this weird system where it's like this subtracting. You can check my math if you want, right? From I equals 1 to k of nk c ni ci. All right, so that's for the first half, right? That's for the half where everything's being incremented. So I guess a note I will make here, right, is that this is for the incrementing stuff, and this other stuff on the right is for the decrement stuff, right? So this is your like increment formula. I'm sorry, guys, this video is really getting away from me. All right, this is like your increment formula. Okay, and then for decrement, you have a different case, right? So it starts from n is k plus 1 minus x times c to the k plus 1 plus n is k plus 2 minus x c to the k plus 1, right? Because now we're dealing with the case where it's decrementing, right? How much do you have to decrement to get n to k? This is corresponding to how much do you have to increment to get n to k, right? So the values are swapped, right? So that's kind of what gets rid of this absolute thing. So then it lets me do some operations to find the relationships between things. And then we'll use this operation to simplify our problem. Believe me. Okay. And this is literally how I solved it 2 days ago, right? I'm just walking through like, okay, what's the relationship? I'm basically just massaging it to get it somewhere where I can think about it in terms of something else, and then it's more efficient to solve, right? Because this does give you the solution, it's just too inefficient. So can we reuse information doing this? And usually when you have sums, you can. Okay, nk minus 1, nk plus 2, all the way to n to the n minus x c to the n. All right, that'll be our last incrementing value over here. Okay, so again, let's do some operations to try to figure out what the relationship between these things are. And I promise this will all make sense in the end. I know it seems like it's very dark right now and that we're just doing random things, but trust me, this is just the process, okay? I didn't say it was without math. It's just not. Okay, so I distributed terms here. Now, what I'm going to say that I can do is, well, I can combine. Again, I have this weird sum thing where I have n starting from k plus 1 to n. I have n to the I, c to the I. And then here I have minus x times c to the k plus 1 plus c to the k plus 2 plus ... all the way to c to the n. All right, so this is our increasing kind of situation here. I mean, it's the opposite. This is the decreasing part. Okay, now you might be like, well, why did we just do all that, man? Like, what's the purpose of doing that? Well, what you'll notice is our whole formula is these two things together, right? I had to do all this to get rid of the absolute value. That's kind of the problem here, is that absolute make this really complicated. Right, but this is the whole cost of one operation. So you might be asking yourself, like, okay, so you took something that looked kind of simple and made it more complicated. I mean, these things are equivalent, right? This absolute value thing over here is literally the same thing as this, right? But I made it way more complicated. And why is that? Well, the thing is that you can reuse information for each x value doing this, okay? So this would be the cost for one x value, all right? And you could try this, you would try this for each x value, but you don't need to actually do all of these sums, okay? And I'm going to show you kind of how that works right now, all right? So if we have values like, it's all dependent on these n values, okay? So I'm going to walk through an example, use these formulas, and then show you how you would just modify the formulas simply in constant time to get the next value's cost. Okay, so if you have n1, n2, n3, all the way to nn, all right? Now let's say we're checking an x value that's less than n1, right? So there's actually nothing here, right? Because everything is going to get decremented to x because everything is larger than. So the formula basically states that you would do, you know, n1, and let's say there's cost 1, cost 2, cost 3, all the way to cost x, cost n. Okay? So here what you would do is you'd say, okay, I'm going to do n1 times c1 plus, literally just drawing out this formula in this form, n2 times c2 plus n3 times c3 plus ... cn times nn. So that's this operation. And then I would do minus x times all of the values again. So C1 plus C2 plus C3 Cn. Okay. Now, if I tried another x, so this is the formula for the cost for the first one. Okay, let's move this over so you guys can see it. I apologize again for how freaking complicated this is, but that's just the way it is. That's just the way it is. All right, so this is the first formula. Okay. Let's just move this over so you can see more of it, and I'll deal with the consequences of whatever that entails later. All right. So this is the first formula all written out. Okay. So if I pre-calculate what this is, if I calculate at the beginning, I'll just call that value big N C. Okay, so it's N times C. And if I pre-calculate this value, I'll call that big N C. If I pre-calculate this value, I'll just call that C. Okay, so then this really just becomes, the cost of this is NC minus X times C. Does that make sense, right? I just pre-calculate this once, I pre-calculate this once, and then this is just the formula, okay? The cool thing about that now is if I try another X value here, if I try an X prime, right, which is also less than N1, I just shove the X prime in here, right? The cost of X is this. Right, so I just put the X prime in here. It's the same thing. I've already calculated this value. I already know what that is. I've already calculated this value. I already know what that is. So then I just calculate what the cost is, right? So it's like I've taken this problem and I put it in a way now where you don't have to keep recalculating things, right? Because we've already calculated all this once. We've already calculated all this once. So then I just throw it in this formula and I get the answer. The only time that something changes is when you try an X, we'll call it X double prime here, which is in between C1 and C2, okay? That's going to change the values because then it changes the location of these two things and is going to modify the way that this is solved, okay? So what I'm going to do is say, okay, it's always the same for the location of X, but if X gets bigger and it's in between two values, this formula changes. And how does it change? That'll help us determine. Well, now we have a value on the left we have to use, right? So now there's this X. So X is larger than C1, so we have to decrement from C1. All right, so it's kind of like your K value somewhere in here, right? So now we have X times N1 C1. And then you have to subtract out all the sums up to K. So minus N1 C1. And then on the other side, you have the same thing with the exception of C1, right? Still this one, except now C1's to the left, so only this right formula is included. So I'm just going to take this out and duplicate it in like that. And then I'll just say, well, this C1's now gone, and the C1's gone from here. But besides that, it's the same exact thing. So that's where we can reuse information, right? Because this is the same formula, more or less. So it looks like this now. And again, it is far too big to be seen. As per usual, this stuff is very large and crazy. Okay, so I guess this is the full thing. I had to put on 2 lines so you can see it. So what's the difference between this new formula and the original formula? Well, since we've increased one, now we have one that's in the left and all the rest that are in the right. Okay, so basically I removed the running sum to the left here from there. I removed C1 from this sum. I removed N1C1 from this sum. But I'm trying to say what I have to do here to make this sum into this sum. And that's what's going to give us efficiency. Okay, I promise. All right. And then I added in XNC1. So I added N1C1 to this sum. And I added N1C1 to this sum. Okay. Now, if I did another X triple prime that was in between here, what would that look like? Well, I would take this same thing and I would add N1C1 to it. I'd add N2C2 to it. Right, I'd add N2C2 to this thing. Did I mess something up here? It's supposed to be just C1. N1C1. Okay, so sorry about that little confusion there. But N1C1, to get C2, I would just add C1 and C2 to this mix. I would add N2C2 to this mix. Then I would subtract N2C2 from this mix and from this mix. Because on this side, it's adding that, so you subtract that out. So then now would be N3C3, because I subtracted out. I'm subtracting out this N2C2. Gosh, this is so horrid, guys, and I really apologize. It's just, this is what it is. Maybe the crazy math problem is simpler. So I remove C2 from this to get it all the way to Cn. Okay, so that's the new formula. So all this is to say is I don't need to recalculate all this stuff. I just need to pocket in things that I've already done. So with relationship to the initial formula, right, which is lost now because we've done so much. And I said if I call this whole thing NC, right, basically said if I call this whole thing NC X times, okay, let's do it with relation to this. So we'll call this thing C, big C prime. So I do X big C prime minus NC prime, okay? And then I add in all of NC prime, all of NC, right? Because what you end up doing is you add in all of NC minus the things that you've already taken out. And I hopefully you guys can review this again and derive these formulas because now it's going to be really complicated and I'm confusing you as I'm saying it. But basically, it's the same thing as before, but you just subtract out the previous thing that you did. So NC minus NC prime. All right. And that's plus X times C minus C prime. Is that plus or minus? Minus that. Sorry. Okay. So let's do some calculations here. So this C is based on where your X value is in this array, right? It was so, the thing that made this problem so freaking complicated is that absolute value, right? If there was no absolute value, this wouldn't be so complicated, but you need to find a spot where things are bigger and larger so you can switch the order of these things, and switching the order of these things switches the order of the signs and what gets added to what. So you may have your whole thing in the beginning, but you need to kind of think about where your X value is, and that'll determine, you know, what is C prime, what is C normal, what is NC prime, what is NC normal, right? Because You know, as soon as I put the x value, like when all the x values were to the left of n1, it was the same thing over and over again. But as soon as x became in between things, now there's c prime things to the left and normal c things to the right. Okay. So if we simplify this, right, it's xc prime. Let's really classify that x is just a small value here. So x c prime minus nc prime plus nc minus nc prime minus xc plus xc prime. And again, I told myself that I would make these small, and then I didn't do it because I'm an idiot. So xc plus xc prime. So notice thing, we have two xc's here. So we have 2xc prime minus 2 nc prime. Right, so that's nc prime, xc, xc, plus nc minus xc. All right, so this is the formula apparently. I might have screwed up, and if we did, we'll have to go back. But basically, all you need to do is, you know, this we can figure out in the beginning. This we can figure out in the beginning. And then these we'd have to calculate as we run through the code. Okay, so these we have to calculate as we run through. The other ones are already pre-calculated. And then we can try each x value as we go. Okay, so let's go ahead and just do that. Let's try at least. So I'm going to write the formula down. So it's 2. So our formulae is 2 times x times, I'm going to call it c prime like that, minus 2 times nc prime like that, plus nc minus x times c. So 2x times c prime minus 2 nc prime plus nc minus x times c. So you see how complicated this shit gets. All right, 2 times x times c prime minus 2 times nc prime plus nc minus x times c. Okay, so we can figure out what c is pretty easy. C is just the sum of the costs. nc is the sum of n times c for n times in zip nums cost, right? Because basically that's these values, you know, these values here, you know, this n1 c1, n2 c2. At the very beginning, it's literally just the whole thing, right? So it's a little bit easier. But as you go through, it becomes, then we'll have c prime equals 0 in the beginning and nc prime equals 0 in the beginning. And all we need to do is just check each number. So let's say res equals float infinity in the beginning. And we'll say, okay, we'll look at each num in nums. We should probably sort nums first. So let's sort nums first, actually. Because we want to figure out when things are bigger or smaller. So we'll say, okay, now that we're trying this number, it's on the left, right? Because it's less than or equal to the current thing we're looking at. So we'll say c prime plus equals c, which is the cost. So we'll do nums and cost. Well, the thing is that cost needs to be sorted according to nums. So we'll do an index array. All right, so this basically lets us, because the problem is when you sort nums, you lose the cost of each thing. So you need them to stay together. So we'll do sorted range length of n length of nums, the key equals for the index, the nums at the index. And we'll look at each index in I. So the prime equals nums of I. The NC prime plus equal nums of I times cost of I. Okay. And then we just run this formula. So we say res equals the minimum of whatever we think res is in this operation. So what would our x value be? Well, we could just try the nums of I itself. Okay. And then this isn't going to work, so we're going to scream and cry because I did a lot of math speaking out loud and I probably screwed up the formula. This I don't really have a problem with because those are just sorted range key lambda. Key equals. Been a while. I haven't had time to do a lot of these, so I haven't been really programming Python that much, so I've kind of lost the edge. This is obviously nothing. It's just something I wrote over, so we'd have to switch back and forth. Negative 58. Yikes. Okay. What if I leave it in the original form? So this is a good exercise in debugging. Right, because I did a lot of like trying to make it look cute, and I think that messed up. Maybe I messed up the math there. We're trying to figure out where the idea makes sense. So now it becomes a question of trying to figure out where along the line I screwed everything up. Right? So let's look at this and let's try to see if we leave it in its form that it was before, is that going to give us a better chance here? Okay. So we have nums of I times C prime minus NC prime plus minus NC prime plus NC minus NC prime plus minus X minus nums of I times C minus C prime. Still negative 58. Guys, I've really screwed this up now. Okay, let's make sure that I wrote this formula down, right? So C prime the whole thing minus NC prime because I calculated these too soon, right? Because now nums and cost, well, no, they're still sorted. They're still the same, I mean. Nobody's watching at this point anyways. But I still would like to figure out what the heck is going on. Look at each index. Nums of I times C prime. Man. I got too confused, man. Shoot. Is the order something wrong here? I think this sign is wrong, but I don't have any way to prove that. I think that actually makes it bigger. Yeah, so it wouldn't be that. Nums of I times C prime. C1 times C2. It's always a sign. Maybe, I think it's this one. Why would I subtract that?
A package for Dulce's order was delivered on May 28th at 6:29 a.m. to the front door.
Or
Containing air
closer.
fryer liners. A package for Dulce's
No, because that would
order was
clear out.
delivered on
It
May
doesn't make sense that it would
28th
clear
at
everything out.
4:34 a.m. to the front door. Containing shower caps.
Alexa, stop. Alexa, stop. Guys, what is wrong with my formula here? Oh man, this is so bad. This is x times C prime minus NC prime plus NC minus NC prime It's crazy because you probably can't see this. Minus NC prime minus x times C minus C prime. So that's the whole formula there. And of course, drawing it out only made me more confused, but let's see if this will give me what I need. So got x times C prime minus NC prime plus NC minus MC prime Why is this wrong? I don't get it. I did this before. I did it. Oh, man. Just having a bad day, I guess. Sorted based on nums of index. You just look at each index in the range. Zip cost. Cost equals cost of index. NC prime plus equal nums of index. All right, let's draw this out. So this would be x times 2 minus NC prime minus 2 times C prime minus C plus, I call that M, this will be NC minus 2 times NC prime. Is that the same thing I have here? So let's work that out. So I have 2xc prime minus xc plus nc minus 2 nc prime. So I have 2 times 2xc prime that's this right here. So this is 2 times x c prime, because a minus that goes over there, minus 2 times nc prime plus if you did this in an interview, you'd be totally screwed. All right, let's get this working out. So x times c prime minus nc prime plus nc prime minus nc prime minus x times c minus x times c prime plus xc times. So this is 2 times x times c prime minus 2 times nc prime plus nc minus nc prime. And isn't that the same thing I had? What the heck's going on? Let's look at this again. Okay. 2 times, this is it right here. All right. 2 times x times c prime minus 2 times nc prime plus nc minus nc prime. What? Shoot, guys. I can't get to the end of this. I'll probably figure this out right after I'm done and look like an idiot, but yeah, I quit on this today. So apologize for the ending not working out, but you do this process and you get to this formula at the end. It's crazy that I did so little work to get it to work this way, and then I draw out the whole problem and I can't seem to get it to work. I'm going to try one more time. One more time. Come on. No one's watching anymore, but I'm going to try one more time. Okay. So this cost is all that. Let's make sure I'm going through a whole thing again. C2 XCK so this is X C prime minus NC prime plus NC minus NC prime minus X C minus C prime. So I get 2xc prime, because these, I get a minus xc. I get minus 2 nc prime, and I get a plus nc. So the final formula is, I don't know if I just somewhere along the lines I messed it up. I mean, I definitely did. But the final formula, according to the second try, is 2 times NC prime. Wait. 2 times x. Okay, we're going to just make x equal nums of I because I'm confusing myself. So 2 times x times c prime minus x times c minus 2 times n c prime plus nc. Negative 58 again. What is going on? 2 times x times c prime minus x times c Can this be I don't understand how this isn't working out. It's so weird. All right, the one that works. Let's just copy in the one that works and see if these things are the same. I just don't understand where my math has gone wrong. So this little c is c prime. This big C is C. This M is NC. And this M is NC prime. And this is nums of I, not nums of index anymore. Oh, so my formula was right. There's just something else that I'm doing wrong here. What else could I be doing wrong? What's the difference between these two things? Nothing. I don't understand what's going on at all. Guys, what is the difference between these two things? I don't understand. I've literally copied over 2 times little c, big C. Big C is the sum of cost, right? Big C is the sum of cost. Big M is the sum of M. So my formula was right. There's just something else going on here, and I can't figure out what the heck it is. And it's so weird. They are the same. right, what if I do this? I don't know why this would even matter. I really don't understand what is going on with this right now. There's something so obvious that I'm not seeing, and it's driving me crazy. I mean, this video's probably been hours and hours now. I don't even know. I think I've lost myself in the sauce of I'm not coding in PowerShell right now. All right. Well, it's the same actually. Whatever. Why is it doing that? I'm just gonna undo that. Res equals float infinity. Guys, what is going on? I'm so confused. We're gonna just drop this in directly. What? Okay, one by one. Res equals float infinity. Res equals float infinity. Big C equals sum of cost. Little c equals 0. Big NC equals sum of NC for num's cost. Little NC equals 0. For I in sorted range length of nums, key equals lambda index. CP little c plus equal. Oh. Oh. You gotta be kidding me, dude. All that work, checking my formula. Formula was fine all along. Just added the wrong thing in the freaking thing. Oh my gosh. That's so frustrating. Okay. Anyways, nobody's watching anymore, but time. Not gonna go into it. O of n. O of n log n, because you have to sort the system first, and then you have to do it. Space to create these arrays. Well, actually, no, you just create these two variables and update them, so that's O of 1. Or O of n log n, depending on how you sort. All right, that's all I can handle today. I apologize, guys.